In this video, I will go over rules of exponents. So we are to find the product of m to the 6th power times m to the 8th power. And if you think about what that means, you have 6 m's being multiplied. Then you're going to multiply it by 8 more m's. So what we will want to do is add our exponents. In this example, we have coefficients and we have variables. We also have exponents. So you have to decide, do the exponents belong to just the variable, or do they also belong to the coefficient? The 3 only belongs to the r, not the -5. The 4 only belongs to the r, not the 6. So what we want to do is multiply our coefficients together, -5 times 6 times -3, and multiply our variables together, r to the 3rd power times r to the 4th power times r. So -5 times 6 times -3 gives me a positive 90. R to the 3rd, that's 3 r's being multiplied together. R to the 4th is 4 r's being multiplied together. So we end up with 90 r to the 8th power. Now here we have two different exponents. We have 7 to the 3rd power to the 5th power, and 2 to the 5th, y to the 3rd to the 4th power. One common way to think about this is that you're distributing the 5 to the 3 on example A, even though it's not really distribution. That would be an incorrect word to use, but I think a useful idea. Another thing to think about is that 5th power means you have 7 to the 3rd power times itself 5 times. In other words, you have 3 sets of 5 or 15, so 7 to the 15th. For part B, again, I can think of distributing that 4 to each item inside the parentheses, which again, it's not really distribution, but it's a useful idea. But I also can think of it as having 4 2 to the 5ths times 4 y to the 3rds. So now I have 2 to the 20th times y to the 12th. Because 2 to the 20th is such a big number, there's no need to simplify that out. We'll just leave it 2 to the 20th. I have 4 to the 3rd over z to the 2nd power raised to the 5th power. So like previous examples, that 5 belongs to both the numerator as well as the denominator. So we have 4 to the 15th over z to the 10th. On the bottom, I have -3a to the 3rd power over bc to the 4th power squared. Each item inside the parentheses has the exponent 2 applied to it. So the -3, the a to the 3rd power, the b, and the c to the 4th power all have that 2 exponent applied to it, which is how we end up with 9a to the 6th power, b to the 2nd power, c to the 8th power. Now, 0 power, anything to the 0 power is equal to 1. So a is just straight up 1. B is actually -1 because that negative doesn't have anything to do with that exponent. So I have a -8 to the 0 power, or -1. C makes it very clear that the negative and the 8 are both part of that 0 exponent. So C is 1. D is -1 again, because even though the 0 applies to the -8 inside the parentheses, there's still the negative outside the parentheses. And part E, everything is to the 0 power. So that's another value of 1. And they're saying that that only applies as long as B does not equal 0.